So how do we take this velocity graph with uncertainty and to determine what the acceleration is doing? Well, we want to know if it's curving up, curving down, or staying straight, because curving up would be increasing velocity, curving up would be increasing acceleration, curving down would be decreasing acceleration, and straight would be constant acceleration, because remember the slope of a velocity graph is the acceleration. So a good way to analyze this is to add a trend line. So we can click here, go to add trend line. Let's do it here, add trend line, and then we can go to more options. Down here at the bottom, click more options, and this comes up. And we like to always display the equation and also display it R squared so we can see how it's doing. Now what this does is it fits the straight line that it can to all the data, and we got to look at it here. How well does it fit? One thing, it should go through 0 because we know it started with 0 speed, and the intercept tells us that. So right here it looks like the intercept says -4. Well, we know the car did not start at -4 speed, it started at 0. So this tells us that maybe the data is a little bit off here. We can also look through and see, does this line go through our error bars? And it looks pretty good, although here it's a little bit sketchy down below. We could think maybe is that because our error is too small. We can increase the uncertainty there to check, or look at the video to see. But overall, it looks like it's pretty straight line. Although a little bit funny out here. It looks like it's a little bit above some of these points, even though the error is large. And we give a slope here of 328.0. So that would be our acceleration with this data. Sometimes things get a little strange out at the end, and it's worth to look at just the beginning of the video. A nice way to do that is to copy this graph. I'll go to copy, and then I'll just paste it down here. And instead of looking at all my data, so up to 0.8 seconds, I'm curious what happens if I just look at the beginning part, or the initial part. And we do this on Tracker by selecting the data. It works a little bit easier, but this one, can we get to? I'm going to look at the first, say I'll go up to 20 points here, and I'll see how does my fit change. So now that we're at 20 points, there is all my points, and here is just the top 20. When you're comparing these, sometimes it's useful to match the axes, so that's going up to 1 second. So I'm going to click change this here to 1 second. And then what happens is it's a lot easier for me to compare these graphs, because I can see this is all the time, and now I'm getting rid of these points and just seeing the first part. And when I do that here, I still get a negative intercept and 328 for my slope, which we can see is not much of a change, right? So that's saying that my extra data out here is not changing my answer. I still have a little bit of a negative on the intercept, but I'm still getting the same slope. So that's a good sign that it looks like all of my data is pretty good, even though the error bars are larger, because it's not changing the equation of the trend line. So one thing we do have to say is, what's the acceleration from this? And the acceleration is the value of the slope of the fit line. So in this equation here, my acceleration would be 328.08 centimeters per second, because that's how my velocity is changing every second. It's going up by 328. And if you look at that here, in 1 second, my velocity should go up to 328, which would be right here, which would fall on this line. So that's what the acceleration means. It's what is the slope of the velocity graph.